All right, so this last section with Chapter 5 in derivatives, there is quite a bit of stuff on here for you to read through. So we have a lot of rules, we have properties, lots of things to recap, and this is 100% all of Algebra 1 and 2. So all this stuff came up in those classes at one point. So again, you've got rules of exponents on the top. We have logs now, but the log properties still hold true to what we were doing with natural logs and exponentials. Multiplication means addition, subtraction means division, an exponent is a leading coefficient. You have some of the properties in terms of inverses in the middle of the page, and then we'll get to derivatives on the bottom down here. So before we do anything though, we're going to recap some of the algebraic ways of solving these. So in Algebra 2, what we used to do is if you had 3 to the x equals 1 over 27, your goal for this type of problem, because you don't see any extra words there, is to get it down to the same base. So you say to yourself, oh, well, 27 I can get in terms of 3's. So 3 to the x on the left is good, but 1 over 27, well, we know 1 over 27 is 1 over 3 to the third, but let me bring that 3 up, which makes it 3 to the negative third. And then if both of your bases are the same, they sort of cancel each other out. And then you can say that x equals negative 3, which would be what makes this statement true. So again, your goal is to get it to be the same base. So same base. The difference, though, with b is you see the word log. So this is where I like to draw my circle. So I'm going to make a circle, and I do this. And what that means is, to solve this, it's 2 to the negative 4 is equal to x. Well, 2 to the negative 4 would be 1 over 2 to the fourth, which would be 1 over 16. So my final answer would be 1 over 16. So when you have a log, you want to get it into the same base. I can go over that here and just reiterate that. If I were to make a circle here, a to the 0 is equal to 1, and that is a true statement because anything raised to the 0 is always equal to 1. Now on the bottom there, that is where our 4 derivatives that come up in this section. They are all odd ones, they're all weird, but realize the first 2 relate to each other and the second 2 do, so it's really only 2 new ones. Okay, what you though would need to keep in mind is you always have to make sure that you are always adding the fact that you have to multiply by the derivative of that exponent. In this case, and then you have to make sure that you are multiplying by the derivative of x down here with number 3. So you always need to make sure you finish it off with that. That's why I kept writing different versions of that property there. All right, so let's try some of these. So we've got y equals 2 raised to the x power. So that's property number 1. So I'm going to do 1 y prime equals, so I do ln, it's ln of a, so that's ln of 2, times a to the x, which is my original problem, which is 2 to the x. And there is nothing else that can be done. So even though these look very weird and hard, they're actually a little bit easier because there's not much simplifying that can happen. So in the first case with a, you were only given the exponent equal to x. Nothing was added. So here's b. Same problem, but now it's 3x. So this is where the slight little extra piece comes in. So start off the same way. So it's ln of a, so ln of 2, times your original problem, which is 2 to the 3x. But then again, I told you have to make sure that you're multiplying by the derivative of the exponent, which would be 3. So now any leading coefficient or number has to come in front, and then the 2 to the 3x would have to come second for that. All right, so now with c and d, this is where it shifts to property 3 for the logs. So we've got how it goes. So it's, if we rewrite it from the front page here, so the derivative of log of a to the x is 1 over ln of a times x times the derivative of that x value. All right, so a in this case is 10. So 1 over ln of 10 times cosine x, but then what's the derivative of cosine? That's negative sine. And then you're just going to rewrite it as a single fraction. And you can actually simplify that one step further, and you can just say to me, you can say negative tan x over ln of 10, because sine over cosine is tangent. Now with D, what you want to do is you want to rewrite it. And we're going to expand it out. Rewrite first, we're going to expand. Okay, so this is our properties. So we have division, get rid of it. In addition, I'm just going to make that to the 1/2. Now also with that 1/2, I'm going to bring that in front. So I'm not even dealing with the 1/2. The second term doesn't change. All right, so both of these are using that property we just used for C. So we have 1/2 times 1 over the ln of 3 times x times 1 minus 1 over ln of 3 times x plus 5 times 1. So that derivative, when we just simplify it, we've got two fractions. We get 1 over 2 ln of 3 times x. Just put the parentheses so I know it's not 3x. And then we have 1 over ln of 3 times x plus 5 for that one. Now the only last part that comes in, just because we are dealing with exponents and exponentials, is something called compound interest. So you could be compounding quarterly, continuously, monthly, and there's two formulas. So if you are compounding a certain amount of times per year, that's the formula you would use. But if you're compounding continuously on a daily basis, then that's the formula. And they have to tell you that in the question itself. But each of those variables, P stands for the amount of deposit, so what you start with. T is the number of years. A is the balance you end up with at the end. R is your interest rate, and you have to write it as a decimal. And N is the number of times you're compounding. And then you don't have to worry about this limit stuff. We're done with limits. All right, so one example here, but has 3 parts. A deposit of $2,500, so that's our P, is made into an account that pays an annual interest rate of 10%. Well, R would then be 0.10. Find the balance in the account at the end of 5 years. So T is 5, and we are looking for A. So if we're going quarterly, that means that our N value is 4 times a year. So A is equal to 2,500, parentheses 1 plus 0.10 over 4, raised to the 4 times 5 power. Be careful how much you simplify at once here. I'm actually going to write it underneath it. And we end up with a value for this guy of being $44,096.54. For B, if we're compounding monthly, that means N is equal to 12. Same formula that we just used for A. Everything is staying the same except the 4 is now becoming a 12. And when we do that, we get 4,113.27. And then for continuously, this is where the equation changes.